Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode ID 2845, count of interesting subarrays. This problem is based on the concept of prefix sum and asked in Google. Marked as medium, and also the problem statement is a bit tricky, but don't worry, I will just make it easy for you. Let's have a look on the problem statement. You are given 0 index integer array nums, and integer modulo, integer k. These three values are given to us. And our task is to find the count of subarrays that are interesting. And a subarray is interesting if it follows the condition as below. Subarray is like a piece. Let's say this is the array. A piece of that array starting from L to R is interesting if this condition holds true. This is they are saying. Let count with a count of indices in the range such that this condition is true. So first of all, we need to calculate the count, or you can say some value, and that value, if I take remainder with modulo, is equal to k. So this is something I need to validate. First of all, I need to calculate the count. Count is the number of indices in the range such that nums of I modulo taking modulus with modulo value is equal to k. So for every value of I where this condition is true, I'm going to add 1 to this count variable, and at the end for this subarray, if the count value, if I take remainder with modulo is equal to k, then that is an interesting subarray, and that subarray is also going to contribute 1 to the answer. Return the integer denoting the count of interesting subarrays. This is just a definition of subarray, contiguous non-empty sequence of element within an array. And this is the problem statement. I will explain it to you again with the help of an example. Before that, let's have a look at the constraints as well. Num's length will go till 10 to the power 5. It's 10 to the power 5, so definitely we can't go n square in this case. We'll just try to find some better way to do it. Any value in this nums array is going till 10 to the power 9. This modulo value is also going till 10 to the power 9. K is a valid valid remainder for any modulo. For any value 4, if I just take any value x and take remainder with 4, I'm going to get values from 0 to 3. The same way they are saying that k is that value. Okay, so what is given to us? We are given an integer array 3196. Positive integers we are going to have. Along with that, a modulo value is given, k value is given, and what we have to find out is count of interesting subarrays. For now, you just remember that we have to calculate the count of interesting subarrays. Okay, we are going to calculate the count. Count we can easily figure out using inc plus 1 if the array is interesting or not. And how do we get to know that the subarray is interesting? Subarray is interesting if this count value taking modulus with this modulo value is equal to k. Let's say this count value is 4 and k value is 0 and k modulus value is 3. In this case the remainder is 1, so this is not a valid subarray. So for any subarray, the value of count having remainder with modulo is equal to k, then that is going to contribute 1 to the answer. That is an interesting subarray. And what is the definition of count? This is the definition of count given in the problem statement. We'll have a look later. And the condition for an subarray to be interesting is this: count modulo is equal to k. So just to make it very simple, if I just remove this count and make it sum, right? Count means how many elements are there. If I just remove it and make it sum, and if I just remove this scene of modulo as well, right, just remove this modulo as well, sum is equal to k. Any subarray whose sum is equal to k. So this is the problem which most of us are already familiar with. Subarray sum equal to k. And this problem is a very important problem. You can see there are so many companies out there in this thumbnail. And if you are not aware of this problem and you are new to the concept of prefix sum, I would recommend you go and watch this video. I'm going to attach the link in the description below, and consider it as a prerequisite problem to this. Now I assume that you are having some basic understanding of this prefix sum. Here what we need to know is subarray whose count value is following this condition, taking modulus with modulo is equal to k. Let me take the same example again, 3196. So in this problem I need to calculate all the subarrays, sum of all the subarrays for which the count value is going to satisfy this condition. Count taking modulo with modulus is equal to k. Let's just ignore this modulo for now. Count is equal to k. For any subarray, the count value is equal to k. If you just think in terms of brute force, then we can easily do it. That for every value of left, we can find out every value of right, and from left to right we have our subarrays. And while calculating the subarray, while moving for the inner loop for r, I can easily check the value of this count and use this condition, apply this condition like count remainder with modulo is equal to k. But we are not going to have a look on the brute force. In case you still need to know how the brute force is going to work, you can have a look on this video. Let's try to have a look on the better approach where I need to know the count, where the count is equal to k. I'm not worried about the modulus for now. Count is equal to k. And what is the count? Count is something, any value in this array. If I take modulus with m, it is equal to k, then that is the count. Let's say if I just take a piece of this subarray, piece of this array, and this is my subarray, and in this subarray I need to know the count. What is the count? Count of this value. And this value, if it is going to contribute to the count, it is going to contribute 1 to the answer or 0 to the answer. So first of all, let's reduce the problem statement, that whether any item is going to contribute to this count or not. The array is 3196. 3196. And what is the count? For any element, any value in this array, if I take modulo with m, if it is equal to k, then that is a contribution to answer or contribution to count, otherwise 0. So let me just reduce this array to my special array where I can easily know whether that element is going to be considered in this count or not. For that I just need to directly check the condition. Modulo value is 3 and k value is 0. So first element is 3. If I just take modulo with m value is 3. 3 modulus 3 is 0, which is equal to k or not? K is also 0. So yes, this is equal to k, and this item is going to contribute to the answer. What about 1? 1 modulus 3 is 1, which is not equal to 0, which is our k. So it is not going to contribute to the answer. And what about 9? 9 modulus 3 is 0, which is equal to k. Yes, this is contributing to this count. And what about 6? 6 modulus 3. 3 to the 6 and remainder is 0. So 6 is also going to contribute to the answer. So now my array is reduced to this one. And this array, I easily get to know that what element is going to contribute or what element is not going to contribute. So if someone say that what is the value of count starting from index 0 to 2. If I mark the indices, index 0, index 1, index 2, index 3. From 0 to 2, the value of count is 2. 1 plus 1. So if you know the value of count, you can easily check. Count modulus m, or let's say skip this modulo. Count is equal to k or not. Right? If you directly get to know the count, you can directly say whether count is equal to k or not. And we have to check count for every single subarray. Every single subarray means every value of I and j. If we go and check for every single value of n, I and j, it is going to be order of n square time, quadratic time. But we have to keep it linear time. And to make it a linear time, we can utilize range sum query. Range sum query. If you are not aware of this concept, you can have a look on this problem as well. Problem statement is also range sum query. But it's quite intuitive that if you want to check sum from I to j, and this value is dependent on two variables, I and j. If I write it like this, from 0 to j, if I just calculate the sum, and this is I want sum from I to j, I can reduce the sum from 0 to I minus 1. 0 to I minus 1. Now what I have done is, I have reduced this value to this formula. And why I have done this? Because this value is dependent on two variables. That two variables will lead to order of n square time, and this formula is dependent on only one variable. This is index, and index value will go from 0 to n minus 1. If there are n element in the array, and I am going to have n queries like this, from 0 to I index, 0 to j index. What I am saying is, let's say the array is something like this, 1 0 1 1, and this array is of size 4. If I want to know sum of this array from I to j, I can easily say that if you know sum of I to 0 to I minus 1, if you know the sum of 0 to j, then you will be easily get the answer. It means starting from 0, if you know the sum of every single index, it means starting from 0 to 0, sum is 1. Starting from 0 to 1, sum is also 1. And starting from 0 to 2, it is 2. Starting from 0 to 3, it is 3. 2 plus 1, which is 3. What I have taken here is, I have taken prefix sum, or you can say running sum. So prefix sum I have taken. If now you are going to say that what is the value, what is the count value in the range 0 to 2, I will directly see what is the count value from 0 to, not 0 to 2, let me take a variable, let me take an example from 1 to 2. Then I will directly say from 0 to 2, what is the value? That is 2. Minus 0 to 1 minus 0, that is 0. 0 to 0 is 1. So it is 1. From 1 to 2, this is 1 to 2. The value is 1. And this is range sum query, utilizing prefix sum to finding the number of element or sum within the range. So here what I have done is, this count variable, I am directly able to get the count variable for any subarray. And I am left with only one condition, whether this count is equal to k or not. From I to j, I need to know the count. I am able to get the count. And ij I am utilizing for prefix sum. Prefix sum is 1 1 2 3. 1 1 2 3. I need to choose an array. Let's say array is like this. This array. In this array, what is the value? If I just take the sum of this sum minus whatever is the previous sum, this value should be equal to k. If that value is equal to k, I can say that for this subarray, the count value is equal to k. This is similar to the subarray with sum k. Subarray with sum k, if let's say I want to get the subarray with sum k, I know the sum till this moment, that is s. I need to reduce some sum, that is, let's say, sum previous, and after that this value might be equal to k. So for any value of s, if I know the value of s, if I know the value of k, I can see whether there is any portion that I can remove from my prefix sum, so that I will be able to get sum equal to my desired sum. what I'm saying is the count, if let's say I am able to if I want to get count equal to k, it means that I have all the prefixes. I want a subarray where the count is k. I can directly get what is the value of sum of counts at this moment, that is s. I want to remove some portion such that this remaining portion become equal to k. Let's say the removing portion is sum previous. Sum minus sum previous is equal to k. From this sum, reduce or delete a portion such that the remaining portion is equal to k, and that is something I can get from this equation. And what is s? S is my running sum. If I just iterate over my prefix sum array, that s value is my running sum. What is running sum? So first step is you can pre-compute this prefix sum. The second step is you just keep on going into the given array 1011 that we prepared using 3196. This is the given subarray, and from this array this is reduced to this value, and over this subarray, over this array, I can do the running sum. That is like counting prefix sum without storing it, because when I'm at index 2, I'm only concerned about the sum at index 2, and if there is any sum previous, such that if that value I reduce from the sum, I'm getting remaining value equal to k. So this idea I can implement to get the answer. Let me show it again. 3196. This array. In this array, I want to know the count, because for me and subarray to be equal to become a spatial subarray, interesting subarray, it should follow this condition. This condition that count modulo equal to k. For this array, this value of count taking remainder with m should be equal to k, and if I have to apply this condition over the count, I should be knowing that count. And what is this count? Count is sum of all the indices where the value with the modulo m is equal to k. So this value can either be yes or no. So I am reducing my subarray with this value, whether the current element taking modulus with m is equal to k or not. So it got reduced to this array, and this array I am further taking prefix sum. Prefix sum is 1 1 2 3. This is the prefix sum, and in this prefix sum I need to get a piece where the count value is equal to k. And what is these values? These are also the candidate to the count. So sum till this moment is s, sum before this moment is sum previous. If that value is equal to k, it means that remaining portion, this remaining portion is going to be contributed to the answer. So I have s, I have k. How do I have s? Because I am iterating over this array. So sp I need to know. If I just need to know some of the previous sum that I need to remove, it will look like this: s minus k. So this equation is something I need to check. Portion that I need to remove, current running sum minus k. And this sp, what is this sp? This is equal to the same subarray with given sum equal to k. So this is like 1012, 1011. In this array, I am going to calculate the subarray sum equal to k. So this is the condition. If still you are getting confused, you can just comment down below and ask me, or just watch this portion again. So sp, how many instances of sp I have encountered so far? Like from this to this is my current sum, and I want my sum equal to k. So I need to drop some portion, maybe some portion like this, some portion like this, some portion from here, so that I can get my sum equal to k. And what are these values? These values are the sp previous that I need to remove. and that SP will be equal to S minus K. It means that I can take a frequency map of S minus K. It means some prefix portion that I can remove, and for all the prefix portion, if I just keep track in the map, I'll be able to get the answer. But here one more important thing I need to introduce, that is modulus. So S minus SP, if I take modulus, it should be equal to K. Now this condition is something need to be true, and this is the count. So here in this condition, if I just want to know the value of SP is equal to S will remain here, K will come here. S modulo with mod minus K. K is already between this range, and S value will now become in this range. So SP, this should also be taken as a modulo. S minus K. Let's say I have already taken modulo. S minus K, taking remainder with modulo. This condition I need to know, and this value of SP from the frequency map I need to get. Let's make a dry run of our approach on this example, same example. See, first of all, here I need to know all the subarrays from left to right where the count value is taking remainder with modulus giving K. First of all, I need to know the count from any range from left to right. Count value in any range from left to right, it's like a range sum query. So for that, I will be just preparing a prefix over this count. And what is this count? For any value, if I just take modulo of spam, it is equal to K or not, then that is going to contribute 1, otherwise 0. So first of all, I convert this array to this count array. 3, first value is 3, and whether this 3 value is going to contribute or not. 3 is the number, taking modulus with 3 is equal to 0, which is K. Is it true or not? Yes, it is true. So taking 1 modulus 3 equal to 0, it is false, 0. 9 modulus 3, which is 0 equal to 0, that is 1, it is also 1. So this is my array, and here I need to take a prefix sum of it. Prefix sum is 1, 1, 2, 3. Now this is the prefix sum. Prefix sum where 2 means the number of count from 0 to 2. 3 means count from 0 to 3. This second one means count from 0 to 1. So this is how the prefix sum will look like. And if I just mark the indices, it will look like this: 0, 1, 2, 3. And here I need to know every single subarray. It means starting from L and going till R. I want to know any portion whose modulus with M is equal to K. Let's say till this moment the sum is M. How much portion I need to remove, that is something I have considered as SP. So first of all, I need to figure out the SP value, sum of previous value. That is something I can discard. If I can't discard anything, then there is no answer. If I can discard one portion, that is 1 to the answer. Discard 2 portion to the answer. So this value, so what is this sum? This sum is S minus SP, and taking modulus with M, I'm assuming that it is going to return K. So how do I get to find SP value? So this SP value will also be equal to S modulus M minus K modulus M. So this is the value of SP. This is SP, sum of prefix. This portion I need to remove, and I will just capture how many times this portion has encountered so far. For that, I definitely need to take a hash map. Hash map where the value is key. Key is the remainder. Remainder with M. M value is 3. So remainder will definitely be from 0 to n minus 1. Okay. So now let's start our dry run. What are all the variables do we require? First of all, I need to know the index. Index will be started from 0 and it will go on the right direction. and I need to capture an answer variable which is initially 0. That will be my answer. Answer means how many special or interesting subarray we are having. So at I equal to 0, how do I calculate SP? Current running sum is 1 minus what is the value of k? K is 0. Taking modulo with m, which is 3. What is the value I'm getting? I'm getting 1. Do I have any one size portion to remove? No, because map is empty. No, I don't have any one size portion to remove. So move next. But before moving next, just capture this sum that we have found out a portion of size 1. So contributing 1 to this prefix sum equal to 1. Okay, move to next. Moving to next means I is coming at index 1. I is coming at index 1. At index 1, the value of S is 1 minus 0 modulus 3, which is also giving 1. It means I need to know how many one size portion I can remove so that remaining portion will be my desired subarray. I can see in the map there is one size portion coming one time. It means that one portion I can remove. If one portion I can remove, it means from this range starting to 0 to any specific value, one portion if I just remove, then this portion will become valid, and that is going to contribute 1 to the answer. So this one will be added to the answer, and current sum, which is 1, just update in the map. Current sum 1 I have encountered 2 times, and my answer is 1 so far. Now index 1 is also done. Index 2, the current sum is 2 minus value of k, that is 0, taking remainder with 3. What does it come? It comes as 2. Can I remove any portion of size 2 so that I will get my desired run? This statement itself saying that okay, if you just remove this portion of size 2, you will get the desired subarray. And I don't have any portion of size 2 to remove. See, what if the portion is coming as 0? Remove a subarray of size 0. Size 0 subarray we can definitely remove. So we also need to pre-initialize that 0 is coming one time. So this is like adjustment. So this 2 coming back to the 2 is not there. 2 is not there, so not going to contribute to the answer. Ultimately save it in the table and move next. Moving next means moving to the index 3. Index 3, here the sum is 3 minus 0, taking modulus with 3, which is 0 again. How many subarray of size 0 I can remove? Do not remove any subarray. It means that is only one state. So this one is going to be contributing to the answer. Answer is 2 now. And this 0 is coming 2 times. So 0 value will be updated to 2. Ultimately state of the map is 0 size subarray is coming 2 times, 1 is 2 times, 2 is 2 times. Ultimately my answer is also 2. Answer is also 2. And how many at what position I'm getting my answer? I got my answer when I was 1. I got my answer when I was 3. It means when I was 1, I removed one size array. So this portion, see, this array is my candidate. Why this array is my candidate? First of all, count CNT. Count is how many items in this array which is taking remainder with m getting 0. There is only one item. One item taking remainder with 3. Does it 0? No, not 0. So count will remain 0. But 0 remainder m is also 0. So this is valid. And what about the second case? Second case at index 3. At index 3 I got, where I just got to the answer. So at index 3, this portion I removed a 0 size array. 0 size array I removed from this array. 3196. 3196. This is the second contribution to the answer. Here how many count is there? This is one count, this is one count, this is one count. 3 modulus 3 is 0. So this is my second candidate. These two subarrays are interesting subarrays. Okay, so now in this try run you are able to get the interesting subarrays. Let's implement the approach. First of all First of all, I decided to convert this array to my desired array, and let's say for that I am writing a loop I equal to 0, I less than n, I plus plus. And what is this value? N is equal to nums dot size. And here how do I calculate it to the desired array? Current value num dot get I taking modulo with modulo. If this value is equal to k, that value will be considered as 1, otherwise it is considered as 0. And this value I need to use, and over this value I will be calculating my current prefix sum. And prefix sum, we decided that we can keep on calculating while doing the iteration, so running sum we are going to use. And why not we just use directly the running sum in this iteration. So sum plus equal to this value, and before that I need to take a map as well. Map of integer map new hash map. In the map I also needed to make a adjustment that 0 size subarray is having one option, that map dot put for 0 I already have one option, that do not remove any subarray, that is one option. So current sum, I also need to capture the answer as well. Answer is going to be my long, and in this answer I need to return in the end. I have calculated the current sum. Whatever is the current sum, first of all just need to take a modulo. And now what I need to know is previous sum. Previous sum is equal to current sum minus k, and then take the sum again. Now in this sum minus k I need to just take a modulo with this modulo again. And now this is the SP value that I need to know, and I need to know how many times this SP is present. That is something I can get from the map dot get. There might be the possibility that this is not seen so far. Get or default SP comma 0. That is my answer plus equal to this value. And now we have captured the answer, and before returning I can update the current sum in the map. So map dot put for the value of sum, I'm going to get map dot get or default current sum comma 0 plus 1. So this is something I did. Let me see if it is fine or not. Calculated the n map, I have taken put 0 comma 1, long value I am taking. Current sum is, if this condition is true it is 1, otherwise 0. So sum I have already taken the modulo. Sum minus k modulo with modulo. See, there is one more possibility that this sum minus k might come as a negative value, so that if it does not come as a negative value I'm just add one modulo as well. See, this is the same thing, that I need to take minus 2 modulo 5, and if I just try to make it a correct value, I can add one instance of 5, so that I always take a positive number here. Here I also need to initialize the sum int sum with 0, and nums dot get I this value. Let's run over sample test cases. Sample test cases are passed. I'm submitting the problem. It got submitted successfully. I hope you understood the approach. Thank you guys. Thanks for watching. In case you get any doubt, you can comment down below and discuss in the Discord community. Bye bye.